So good evening, everyone, and thank you, Rimvidas, for a nice introduction. I'm really happy to be able to give you this presentation. As mentioned before, I was really introduced nicely, so there isn't much to add, other than that I'm quite passionate about testing activities, other than development activities, and I like seeing code being of high quality, and tests are a key part to making sure that code isn't just doing something, but it works as it should and the quality is high. That's why I like testing, because it helps to keep code at its best. What will you see in this presentation? And why is it important, and why should you take these 2 hours and watch what and listen to what I'm about to talk? You will hear a presentation about BDD methodology, and I put in these 2 hours the content from my experience from the 2 books I've read about BDD. It's BDD Discovery and BDD Formulation. You'll see lots of examples and examples from many different aspects, from story refinement aspect, basically something that everyone does who is involved in development teams. We'll talk about writing good test cases in Gherkin language. So this is again practical for anyone who is writing test scenarios. And we'll talk about how to automate it, how to automate those test scenarios written in Gherkin using C# and specifically SpecFlow. At the end of this presentation, we'll try to bust some myths about BDD. It isn't quite straightforward as it may look from the first sight, but I'll try to give controversial statements or maybe common statements about BDD, how it's used, how it shouldn't be used, and we'll try to deny those statements, prove them wrong based on hands-on experience and logic about what BDD truly is. And this whole presentation will be based on a demo of testing an online shop basket functionality where you can add and remove items in a shopping cart. We'll use SpecFlow, Selenium, and I'll show you running a few tests in action. So here are the topics of this speech about what is BDD. We'll talk about it from those different aspects, and we'll talk about busting myths about BDD in the end, and do a demo of that eShop test code. So let's get it started. And let's start from the very basic definition of what really is BDD and what most people don't quite get right. So we'll stick to this slide for a little longer. So take your time to explore what you see in this picture. On the left, you see a typical C# project layout. And key parts in this picture is this .feature file and steps file. The content parts of these files, the content of it are in these images. This is the code for the feature file, some of it. And this is the code of the steps file. So how does BDD work? We have a human readable feature, and this one reads shopping cart feature, change product quantity as Osha the shopper. I would like to be able to change quantity of shopping cart products so that I can choose how many items I want to buy without going back to a shop. So this is a human readable description of a feature. This part has no meaning in code yet. This doesn't automate anything. The things that automate it are scenarios. So this is a test suite, you could say, description, and a scenario is a single test case. Background is a precondition that is run before every test case, before every scenario. The scenario, the example scenario here is decrement quantity when product quantity in shopping cart is enough. So this means that we can only decrement shopping cart items if their quantity is at least 2. And if it's less than 2, which is 1, we cannot decrement it. So every step in here, every step in every test scenario is made of 3 keywords and 1 or more steps written using that keyword. Those keywords are given, when, then. So given is a precondition, when is an action under test, and then is the expectation. And each of those steps, given, when, and then, they have the code, the underlying code that they bind to. And they bind to based on regex expression that will detect this step text. So in this case, we have product quantity is either some number, exact number, or is at least some number with 0, like that starts from 0 and 9, that has 0 and 9 as digits and repeats multiple times. So this is the regex expression that picks up this given step. And based on this regex expression, we will be able to execute this code in this function. So this is how the general idea of BDD is. Using human readable language, we can create bindings, like create our own testing language and create bindings that does the actual automation code. So that's BDD. Actually, that's just using Gherkin language for testing. That's not quite BDD yet, but we'll get to that quite soon. So to summarize this slide, we have a feature file, which is written in a human readable language with Gherkin. And we have a steps file, which has bindings for the following given, when, and then steps. And through attribute that you can see here, we are able to bind this text into this code. Let's move on. As mentioned, a feature in BDD is written using those 3 keywords, given, when, then, and using other keywords like feature, background, and scenario. So feature is a test suite, scenario is a test case, and background is just a context that is for every scenario. So quite simple. And really, to learn Gherkin, from my experience, when a new person joins the team, even an intern tester can learn Gherkin language, just those keywords, and be able to use those keywords to formulate scenarios. They can learn it in under half a day. So using this language is quite easy, and since it reads as plain English, it's very intuitive to use, even for a non-coder. As mentioned, that's what BDD uses. And on top of that, BDD should also use examples-driven formal documentation. What we have in scenarios are supposed to be single examples on that test case. And the point of those examples, they are supposed to act as documentation, examples-driven formal documentation. And when we have this, we have tests that verify our documentation. And since tests verify documentation, we have documentation that's always in sync with code. And this is absolutely great. It helps us to trust what's written in documentation and trust that it's 100% true because the tests are passing. So that's quite important, having trust to our documentation. And this whole thing is called living documentation. BDD might often be synonymized as living documentation. However, the perception of BDD often is understood simply as a tool for automated testing. So people may write a feature like this. So a question to you guys, what do you think is wrong with this test case, with this scenario? What problems does it have? And I'll give you a hint, it has at least a few problems. There isn't just one problem. So I expect someone would like to answer. Do we have anyone who would like to answer? What is wrong with this scenario, with this test case?
Okay, so we have a raise of the hand. Mantas, right?
Yeah, hello everyone.
Hey.
Hello. So the first problem I see that there is a lot of then keys, and that's like, I don't know, 4 tests in one. So if one then like fails, other then also fails. So
that's right.
If the first one fails, so we won't test the second one, third, and fourth one.
Yeah, exactly. What else?
Then the next thing, I do not get what is item quality label. I think it should be more human language. It should use more human language.
So the first 2 points, technical and many test cases in one. Is there anything else?
At the moment, I don't see anything else.
Other points are quite similar to the mentioned ones. It's very convenient to write tests in this format, but they don't serve as documentation. So you have quotation marks for just because you want to add a parameter, you put quotation marks. This problem could be like, it's unclear, like one item, you're not writing one as text, you just want one item. So it might be confusing to see quotation marks for a number when we mean a number and not text. This problem could have been solved by putting regex expression to detect this number without the need of quotation marks. And lastly, we're using I in this test, and almost in all feature tests, I see it being used I as the actor who interacts. Why do you think I is not very good for a test? Would anyone like to answer that? I'll answer the question if nobody wants to answer.
There's a hand, Almantas.
Okay, let's.
Edgar would like to answer.
Yeah. Okay, let's hear
I
it.
think this is the scenario for a user. So it should be user have one item, not I have one item, because we are focusing to the user as a
Yeah.
scenario based. Like.
Yeah, that's correct. When using feature tests, we should be using either personas or roles, and I is quite subjective because who am I? I might be an administrator, I might be a user, I might be someone who just randomly looks anonymously at the items and fails to add them to their shopping cart. So it's quite important to specify who am I. So that's a problem as well. And last thing, when thinking about BDD, people, the selling point they use, they say that tests can be written by a business analyst or a tester. But the point of those tests isn't that someone other than a developer or in general, someone who doesn't have experience in automating stuff writes automation code. That's not the point of BDD. The point of it is quite different. And out of all those issues, we'll see that tests written by a single person in the context of BDD is the worst thing about it. So what is BDD really? And I was surprised after reading the books to see that it's quite formally defined, and it's based on 3 pillars: on discovery or exploration of test scenarios in refinement session. It's also formulation of scenarios using examples given in refinements and turning those examples into scenarios written in Gherkin language. And finally, it's automation, turning scenarios into automated tests. In other words, writing glue code for it. So discovery, formulation, and automation. That's what BDD really stands on. And what people mostly focus is on automation. They do everything to just automate tests, but they forget that the point is to have a human readable documentation that's based on our user stories. So let's explore each pillar individually. But before that, once again, an emphasis: automated tests, the fact that we have them is just a side effect of BDD. It's not the point of BDD, it's just a side effect. We do it through the 3rd pillar, but we can have BDD. Like if we just do automation and miss the other 2 pillars, it's not as bad as having the other 2 pillars, which is having great documentation with examples, but not automated documentation. Having bad documentation and bad examples, but automating those isn't what we want to achieve with BDD. We want more. So BDD is available, is compatible with TDD. You can have both in a single loop. And here is a reference given by Jessica Maurhan, the loop in which the 2, BDD and TDD, communicates together. And what does this mean? It's how to write, how to develop, how to do testing so that testing goes before development. So this loop says that first you write a feature test for code that doesn't exist. Obviously, that test will fail. Then you write a unit test for code that doesn't exist. Obviously, that test will fail. And then you keep adding code until that test passes, and then you rerun your feature test and see whether that passes. And until you have a passing feature test, you keep adding unit tests, you keep adding code until you have both unit tests and feature tests passing. And obviously you do refactoring in between. And that's a really nice loop of how the two communicate together. It happens rarely because it's quite difficult to pull, but it's difficult to pull not because it's hard, because it's just a habit that people need to develop. It's hard to inverse your thinking and start from a test, but it's possible, and it's not even difficult. You just need to develop a habit. Just start, do, practice until it becomes natural to you. Let's move on to talking about each pillar more hands-on through examples, through concrete stuff, and discovery. The first one, we'll talk about story refinement through examples. A question to you guys: how do you present theory and principles so that it is easier understood? Like, what would you wish you had next to theory to make it more understandable? What supplements theory very well? Would anyone like to answer that question? And someone said examples. Rita said examples. And that's right. Practical application of theory, examples, is what supplements theory the best. And that's what we want to see in our user stories as well, ideally. User stories could be looked at as just theory, and examples should be the glue that makes it very understandable. And through those examples, you can make people very involved in the story. So yes, we give examples. And this is a typical user story that is unrefined. There is nothing wrong with it. This is just what product owner usually gives us, a little bit of background, what the problem is, something about what they want to achieve. So they just explain the problem that currently users have a read-only shopping cart where they can only do a confirmation of items they added to the shopping cart throughout the shopping process. But in that confirmation window that we currently have, the user cannot change neither the items nor their quantity. They can either confirm them or not. And that's not very user-friendly. So the product owner said they want to change, to add a feature so that a person could change item quantity. So looking at this user story, what do you think is missing from it? Why do we refine user stories? What do we want to achieve with them? It's 2 words, answer. Acceptance criteria, that's right. That's what's missing in this user story. So we want to refine a story so that we get the criteria which defines what constitutes a completed story. What can we call a story that's completed? And in this example, we might sometimes see stories which are refined in a technical way. For example, a button, a text box are both technical elements. So this acceptance criteria does explain what we would imagine as done. It draws a pretty good picture. However, it solutionizes how we should do it instead of telling us what should be done. So someone reading this story and seeing a different implementation achieving what the product owner had in mind might not be accepted simply because the implementation is different. And this is not what we want to see in user stories. So sometimes drawing such a technical picture might seem like a good idea, and it may be, but only at first glance. Technical user stories are not great because they solutionize how work should be done, and we don't want that. We want freedom to do work, and we want to be able to innovate. Solutionizing doesn't allow us to innovate. We want to come up with our own solutions. We just want to see a problem and what needs, what the user wants, and then implemented it in our own way. Having technical stories, even when it's very convenient, even when it's the only way to do it, leaves a bad culture. And such bad culture, and this bad culture is called broken windows culture. And broken window in this context is a technical story. When you keep leaving broken windows in technical in user stories, when you make them technical, it spreads through the backlog. If you did it once, if you created the technical story once, why not create another one? You are doing technical stories after all. There are some examples. So you might subconsciously keep on doing technical stories, and it's just not a habit you want to be in. Technical details change. You want to focus on what, not the how. So avoid those, even if it's convenient. And we escaped those technical details. Instead of saying it as an acceptance criteria, we moved it to comments. We made it quite simple. And we decided that Gherkin language, writing acceptance criteria in Gherkin language is a good format, because it enforces you to think about preconditions, about inputs, about outputs, about your expectations. But something is still off looking at this acceptance criteria. Of course, it helps. Writing examples, we're more involved, it's more concrete. It's talking about concrete scenarios at this point, but something is still off. What do you think is wrong in Gherkin language when you write acceptance criteria in it? What could be done better still? What do you think? Would anyone like to answer? And Gherkin is here, those when and then things in acceptance criteria. So what is wrong? Isn't it quite difficult to understand?
We have the answer from Almantas.
It's like not the answer, but I have a question.
Mm-hmm.
It's really, I do not understand what is like preconditions and what should be done before in order to understand what the goal of this, I don't know, acceptance criteria are.
The preconditions, you mean what state a user must be in order to increase the quantity?
Yeah, what we are talking about, like.
Okay. That's why background helps, as mentioned. A description could mention that we already have a shopping cart. We can assume that we are in the context of shopping cart. That is a good point, that we do miss some context in order to understand what needs to be done. And just because we wrote stuff in Gherkin doesn't help us to answer those questions. And in fact, Gherkin makes it quite verbose, and it obfuscates the things that really matter. And for now, I'll pause and I'll go to an example page of what we're testing, so that maybe it will be easier to understand the context. So this is a website, and you'll get a link of this code and website and the tests after the presentation. And what we are testing is we are selecting some item from the selection page, and we add one item to a cart, at least one item, there can be more. And I want to check the shopping cart after I add the item. I can do it by clicking this button or going to the page from after I add the item to the cart. And from here, I can change the quantity, the item quantity. And as you can see, I cannot change the item quantity below 1. And as I change the quantity, the totals also get updated automatically. So this is what we are testing. An item is in the bag, and I'm just changing the quantity of it. So this is the feature under test, is interactable through those buttons for now. And we're testing under what conditions and how we can change the quantity of a product in a shopping cart. So going back to the slides, Gherkin is not suitable for acceptance criteria, and the answer is because it is too verbose. And Gherkin is code, after all. You will take time to write good code, and trying to do everything in refinement and be so naive and think that Gherkin code written in Gherkin that we define acceptance criteria as, thinking that such code will not need to be rewritten, refined, is too naive. And if you just take these criteria and try to create automated tests from it, it won't be good enough. And if you do it, you'll get definitely not the best out of your documentation. It's not 100% clear. You need to think more about how to make it understandable. So writing code, documentation in acceptance criteria is just not very viable. So that's why it's not great. So we didn't gather to code during a refinement. We gathered to get the requirements right. So how should it look better? It doesn't matter what format you use for acceptance criteria, as long as you provide examples. And in this case, there is no Gherkin. There are just some abstract statements which are good enough to draw a concrete picture under what conditions can we do the changes of item quantity. If item quantity is more than 1, this is a little mistake. When we decrement item quantity, when it's more than 1, it gets decremented. We can type 2 in item quantity and it will be set to 2. If item quantity is 1, the quantity doesn't change. If item quantity is typed, let's say instead of 2, we type letter A, we get some input validation message, the input gets rejected, and so on and so forth. We have very simple scenarios that illustrate a test case and do nothing more. There is no arbitrary format in which we need to write those scenarios. It just provides enough information to know the context, the interaction, and the expected outcome. Ideally, per acceptance criteria, you should have a single example. Let's move on. So keep examples simple. To summarize discovery, the first pillar of BDD, discovery is all about getting examples defined in refinement sessions. Why examples? Examples make you involved. When you have something concrete to talk about, you can be more involved, down to earth. It stimulates your imagination, and it makes you think about things that you might have not thought about before. Examples are perfect and necessary for testing, for the basis of on which tests will be built, and the examples should be minimalistic. They need to be there, but they shouldn't act as documentation, not yet. And we should focus on a single thing being illustrated at once, not multiple acceptance criteria in one example. And the awesome thing about this, when we write requirements in such a way, we will not only detect a bug with a test written before we write code, but so we won't release a bug, we won't deploy a bug, we won't need potentially manual testing effort. It will be picked up before that, but also we won't have unclear requirements. We won't have bugs in requirements if we use examples. Of course, some misunderstandings will happen and some bugs will happen, but they will happen less often. That's why discovery and examples help. Let's go to formulation, the second pillar, and let's focus on understanding why is it not a good idea to do formulation for a one-man or one person. And as mentioned before, we have a technical scenario that talks about specific item, about a URL, about a button that we need to click, about text box that we need to inspect. Once again, great for testing, automation, for automation testing, but not so great for a human to read. So it would be easier if, of course, we would just change that URL to a name of a page. And instead of item quantity text box, if we would write just the property that we are inspecting. And this is how the refactored, more clear scenario of this would be. We have a role shopper, we have a page, not a URL. We have shopping cart page, and we say that item quantity should be 2 and not the item quantity text box should contain text 2. So this is way more easy to read. And we also said that quantity is a property that we are expecting, so we don't really care about that it's text. It's just a number that we want. That's how we want to understand it. We don't need the quotation marks. So don't use concrete data where it doesn't highlight. If we check this example once again, we have Samsung Galaxy A5 pink phone, and we might be asking questions, why is that specific phone model in our shopping cart? Does it matter? And the answer is it doesn't matter. It's just an item. So we can refactor this like this. All we care is that there's a single item in their cart, a single item, so one item. And when they navigate to a cart and change that item quantity, then it should be 2. There was one item, we incremented quantity, now there are 2 items. That's pretty clear. We don't need to care that it's that specific brand and that it's a phone. So that example still has a few problems. The state that we explicitly define sometimes isn't necessary to be defined explicitly. And the problem with some tests, and especially in complex behaviors, is that we provide so much context that we're losing the point of what is actually being tested. So not all state needs to be explicit. Some of it can be ignored. And in this case, we have a shopper has a single item in their cart, and a shopper has navigated the shopping cart page. A shopper increments quantity, then item quantity should be 2. Question to you: which part of this is not necessary? Which part of this could be skipped, ignored, left out, so that it actually increases clarity and doesn't force you to think about the obvious? What do you think is the obvious in this scenario? So question to you guys.
So I think the second part of given is not really necessary in this case.
A second part of given.
Yes, and a shopper has
Yes.
navigated to the shopping cart page.
Yes, so let's see what my opinion was. Whoops. So yes, I I also agree. All we care is that there is a single item, because there is no way you can change the item quantity without being there, so without being in the shopping cart page. So we can omit that detail and just imply it. So it's okay to assume that in the context of shopping cart, change shopping cart item feature, we will be in the shopping cart page. All right, and I see we have a question, so I'll also try to answer that. Algerda said, very nice examples. I would have a question about readability versus interpretation. Should we specify in such a way that there are no debates? What happens if people misunderstand what's described as shopping cart page? All the context needed in terms of understandability of the elements used in a scenario or a feature depends whether it's scenario specific, explain it in scenario description. If it's feature specific or shared across different scenarios, then describe all those definitions and terms, the glossary, in the feature itself, in the feature description. You can add links, story items, everything in the feature, even PR links if you so want. Everything can be done inside those human readable descriptions. They're not code yet. The steps are the given, when, and then. Everything else is just human readable stuff. So if you feel like your code uses terms that are ambiguous and need explanation, explain them in a description, either of a feature or a scenario. So that would be my answer to that. And let's move on. So the background, this isn't quite correct what I have here. Background is, once again, Gherkin. So you don't just write text like this. It misses a given keyword, but that's not the point. As I mentioned, background gives you the context. I could imply that every scenario, when I'm changing shopping cart item quantity, I could imply that that item quantity, that item exists, because I cannot change quantity of something that doesn't exist. So it's useful. It's useful to have it as a background. It's a bit redundant to have it as a step in every scenario to explicitly say that we have a single item in the shopping cart. It's a bit redundant. It's too much. Again, the context that we can omit. But I chose to use a background in this case. I didn't simply omit this context. And why is that? Because when you are reading this scenario, you're reading about some item quantity, and you might wonder, what item are you changing throughout the test scenarios? Are you changing the same item or a different one? Where is the item coming from? And the background answers that. So that's the only reason why a background is in there. It helps, it further increases the readability. If I used it in every scenario, it would reduce readability. But if I just used it in a single scenario, it actually, in a background, it actually helps with documentation aspect and readability. And the shocking part, when I was reading the book, the author said to deprecate altogether the background statement, because we don't want to force the reader to, for every scenario, to also read the background, because if there are many scenarios in one feature, you would have to scroll down, scroll up, scroll down, scroll up, reading the scenario, reading the background, reading the scenario, and switching between the two again and again and again. That's just not viable for readability. So avoid the background statement, because it usually makes readability worse. But there are exceptions, like the one provided before, where it is working quite well. If you want to read more about dry versus damp, or in other words, code that you don't repeat versus code that you repeat in order to increase readability, if you want to read about this topic, that's the link provided in the slide. I highly recommend having a look at it to be more familiar with the topic. Examples table. if you have many test cases, you don't have to write many scenarios. If the only difference in different test cases and different scenarios is the arguments that are used in those scenarios, then it may be a good idea to simply parameterize those tests. And in Gherkin context, parameterized tests are done with an examples table. A table may also be used for object expectations when there is a property, when there is an object with multiple properties that you expect. But for now, let's focus for parameterized tests. So in a scenario, we can have placeholders like duration and cost, and then lookup in a table, and a single line will populate a single scenario data. And we go through these lines and populate these placeholders like this. So for every line in this table, a different test will be run. So there will be 3, 9, 12, 15, 18 tests in total for this table. So this is actually 18 test cases in a single scenario. For those of you who are familiar with Gherkin, you might wonder, why is there no outline keyword here next to scenario? And the answer is the keyword is optional since Gherkin 6. I just wanted to mention that because I haven't seen it in practice that someone wouldn't write this, because even in official documentation, the keyword is provided, but it actually works without one. So just an FYI. One thing to remember, a placeholder is denoted by less and equals signs. So as long as you put some text in less and equals, it will be picked up as a placeholder from the examples table. So what do you think? What do you think is wrong with this table? What do you think are the edge cases being tested here, given this is the code that this table tests? What are the edge cases that are under test, and do you think there is enough test cases for this or not enough? Who would like to answer this question? Does this test everything? Does this test too much?
Hi there.
Yeah, hello.
Yeah, Almantas again. So basically, what do I see that there should be like enough like 4 test cases, like boundary values testing? It should be like enough, like min, maximum, middle, above the maximum, and below the minimum.
I think there would be more than 4 cases needed, but some based on non-changing cost, some examples don't really test anything extra. There are already other cases that test those extra bits. So the highlighted, as you mentioned, examples can simply go away because they don't add any extra value in them. Other cases test the same thing basically, so they can simply be removed. However, other values are quite needed, why are those other values needed? Because they test different edge cases. 0 is obviously a a boundary value, so it must be used. 30 minutes and 1 hour, they're just verifying this case that we crossed some time passed after the time, the parking time, and then we reached the cap, the 1 hour cost cap, which we had 2 hours, so it stood 2 hours, didn't change. And then we have 4 hours, which we can clearly see 4 times 2 is 8. So that's how much it costs per 4 hours. But after 5 and 24 hours, the price didn't change because the cap is €9 per day. So those are quite illustrative and explaining how the price changes, and they cover boundary values, and as well illustrates when the change stops, when the boundary is reached, and when the boundary, another boundary is hit, that it doesn't really change after the boundary is exceeded. So those are the example values. Even after this, there's still some improvements. For example, 2 or 3 weeks, it's still the same condition as you can see here. So we reduced, we can reduce further and simplify this scenario by removing the 3 weeks from it and simply making this 1 week scenario a bit more complex, saying it's 2 weeks and 2 days. So now we test that the week's price and the day's price is working, it sums together stuff, and we don't need a separate test case for 1 week, 2 week, 3 weeks. Just multiple week scenario is enough, because after that there is no more cap, no more boundary. About specific boundary values, I won't talk more about whether 30 minutes or 1 minute or 6 to 1 minute is good. Probably if a minute is a unit, it would be better to be used as a boundary. I agree. But the point isn't to talk about what is a boundary value and how to pick it. The point is that sometimes people just add many test cases and they're happy about it. They think they're good. But the point I want to illustrate here is that the test cases are as simple as they can be, because 6 to 1 minute is a bit more difficult to maybe calculate in your head. In this case, it's not, since the 1 minute doesn't change the price that much. However, if you write 3 weeks instead of 2 weeks, you're just unnecessarily complexing the multiplication for no good reason. So the point here is 2 points. Often we have more test cases than we need. And another thing, we have test cases that require a calculator to be used instead of being self-documenting. So that's what this was trying to illustrate. Let's move on. And we have those numbers and placeholders, and that's great. But in some cases, it might feel like they aren't expressive. What are we testing? Why do we have those test cases? So we add, we can add explanations for every test case in the examples table using an extra column. Again, I rarely see this being done in practice, but why not? This has no impact on code itself. It simply won't be used. This description column is simply a description for a single test case. So when what the 0 minute duration means, it means you didn't park your car. So if you didn't park your car, you don't have to pay anything. And then we have 30 minutes. Why do you pay €2 at 30 minutes? Because that's how much you pay at least for an hour. There is no minute price. You always pay the same per hour. And then you explain the same way every other case. Simple as that. Neat explanations, increase readability, and it doesn't really cost anything to write such an explanation. It's even better than a comment because there is no semantics for this comment. It's literally a description for duration and cost in this case. Great way to explain the intention of a test case. I already asked this question. I think the slide is slightly mixed, not as intended. So I'll skip it and move on to the next one. Multi-line text expectation. In Gherkin, let's say you're testing Web API, it might be useful to provide a JSON as an expectation. So a JSON will be multiple lines, and it might be useful to use multi-line text expectation in Gherkin, and it's defined with 3 backticks or 3 quotes. So you can use this, and then those multiple lines will be interpreted as text. Simple as that. In Gherkin language, star symbol has a special meaning. And the special meaning is that instead of given, when, then, even instead of and keywords, you can simply use a star keyword. So, for example, in this case, you can improve the readability slightly by, instead of saying, then you should get user response, and the user response should have body and status code should be, instead of those and words, because they're not very natural, you can say with body, with status code, and replace those verbose statements with a star. They increase readability. In this case, you could also use a table, but I wouldn't, because there are multiple lines of text, so it doesn't really fit. But providing properties of the same object and chaining them with a star is quite good. It's also very suitable when you have a list of items. For example, if you say in the shopping cart, I have a single t-shirt and a phone. If you write like this, you can simply have those asterisks and define what you have in your cart like this, like that. So use it when either listing items or talking about properties of the step, sub-steps of the previous step, basically. And or but. Once again, but is a keyword that you can use instead of an and. Sometimes you have an opposite meaning. Something happens and something doesn't happen. In this case, we have a failed registration attempt due to server validation. That's a scenario, and it goes like this. Given a client has an invalid register user request, when the client sends a register user request, then a registration entry should be created and the user should not be registered. This even reads quite weird because there is something happened, something didn't happen. And if I'm writing an and in this case, I might miss the fact that it didn't register the user. To better emphasize that something didn't happen, I should use the keyword but. So this scenario simply changes when the client sends a register user request, then a registration entry should be created but user should not be created. So that but now puts quite an emphasis on the things and makes things better. Sometimes it might be tempting to not use the word should for the same reason of increased clarity. But there might be some silly ambiguity if you do not do it. So in this case, given item quantity is 2, when a shopper increments item quantity, then item quantity is 2. So item quantity is 2, a precondition, and then item quantity is 2 as an expectation. It will work in Gherkin actually, because you can have steps, different kind of steps with the same binding. You can have a given and then with the same binding, and it will bind to different code. However, it might look weird when you read it. And the word should, it actually doesn't state the fact that something absolutely is, but it states an assertion. You're asserting, you're careful, you're checking, inspecting something. So it sets an expectation. And in this case, if you change then item quantity should be 2, it makes it slightly more readable, assertive, and it puts emphasis what the assertion is. In this feature, we used tags, a tag like shopping cart, and you can put other tags in your features like manual or payments. And tags have no special meaning in Gherkin language. They're just, once again, something that you can use to increase readability, documentation aspect of things. You can also use tags to pick up in your test code, but the primary reason shouldn't be so that it's easier to test. It should be so that it's easier to understand what are you testing. And at the start, I asked what's wrong with a scenario that has multiple thens and is technical. And in fact, some scenarios that have multiple thens aren't so bad, but those scenarios shouldn't be abused. Sometimes you just want one scenario to test a typical user experience, a typical set of interactions. The so-called sanity test that tests for functionality of your system and goes through one typical scenario of how your system will be used end to end. And to test this, it's quite okay to have journey kind of scenario with multiple thens. There should be only 1, 2, maybe 3 such scenarios in your whole code base, but they are still good and necessary. So this is the example. It talks about basically the whole thing that I did in a journey. In a demo, when I showed how the interaction with the page in order to change the quantity, what things need to happen for the quantity to change. I showed those things at the start, and this basically writes it down in one journey, what you need to do in one journey, how you typically interact. And I see we have a question from Mantas. So Mantas, go ahead and ask one.
Oh, hello. Do you hear me?
Yes.
Yeah, great. I would disagree with you because you can write like 5 tests and they do the same thing that this one do. But I saw one thing that, like, for me, it's like not clear, and you could change those given in the middle of a scenario. you could like add, I don't know, another one to that case. Like this is like when Shona closes the pop-up in the same implementation of the code, and it will be like more readable maybe.
I don't argue that this isn't ideal, but the point of having multiple scenarios in one as a journey is still actually valid, because this, as mentioned, if you see such a test as green, regardless of, let's say, some specific scenarios failing, it might still be acceptable to, let's say, push it forward through environments and test it differently, let's say performance test it, because you're still getting the core functionality working, or let's say MVP is still functioning because this journey is passing. But the problem is, if using those journeys, you test everything in your code base. If that's what you do, then we come to a problem. And the problem is that sometimes I see many test cases like that, which aren't journeys nor scenarios. They're just bad test cases. So in general, you should avoid them. If you don't like it, it's okay not to use it as well. It's much better to have many small scenarios all together rather than having many journeys. Either have a few journeys to supplement it, or don't have them at all if you think it's like a necessary thing. So in general, I would agree that it's not great to have scenarios like that, but sometimes for some cases they're okay. I'll just double check the time. All right, we have roughly 40 minutes. Let me get back to sharing. All right, let's continue. So those were the formulation steps. And now to summarize the formulation pillar, keep in mind to write test scenarios and the Gherkin in a way, not that's simply easy to automate, but that it's easy to understand. It's documentation first. It doesn't matter that you have many test cases. What matters is that they test what they say they test, and that there aren't too many of them, because what matters is documentation aspect, understandability aspect of it, and nothing more. So the last bit, automation, we'll quickly go through some technical details of what I used before I show you a demo. So for .NET ecosystem, there is SpecFlow. For Java, there is Cucumber. And for other languages, there is something similar. For a major language, there's usually something that supports Gherkin and BDD. Selenium for interactions, automated interactions with web. And there's also an extension of Selenium that provides some nice utility methods. So Selenium support for utility methods, Selenium extras, wait helpers to have some more extras to wait for an element to be rendered. And we'll use Chrome for driving our tests for the browser, and fluent assertions to doing actual assertions, because they are very BDD friendly. So when you write a feature, my key tip would be to try to think about it quite in advance and to not start automating it and writing glue code before you are happy with how the feature looks like. Because if you just quickly write a feature and quickly write glue code, you might end up rewarding the feature, and therefore it will be quite nasty when you need to regenerate the glue code and refactor the glue code based on those features. You might end up having duplicate code and just be in a collision of trash code, old code with the new code. So we start writing BDD workflow from a feature. So write a feature first, and when you write a feature, when you're done with writing a feature, one scenario for now, let's say, you can right-click on that feature file, anywhere in that feature file, and if you install SpecFlow plugin, it allows you to generate steps. If you right-click anywhere in that feature file and select define steps, this window will appear. And in this window, you select the unbound steps, the steps that you haven't used before, that you haven't written glue code for. And if you click copy to clipboard, it will copy those steps in this file name. If you copy to clipboard, it will copy it as it says to clipboard. If you click create, it will also create that file. My advice is to not copy, to not create this file, because step definitions class name is a bit redundant. It could be simply called steps. So if you say name of feature steps, that's pretty good enough. So copy to clipboard and then paste it to whatever glue code class you create. So create a new class, annotate it with attribute called binding, and that will be pretty much it, and paste your code in such a class. Won't go too much into this written detail because I'll soon show you how this looks in practice once again. And I won't go into those technical details, how those technical details look like. I will show the demo itself. Because the point isn't code here, the point is understanding the principle. So I'll show what I showed in those screenshots, but in action. So I select a feature from the list. I'll call it my new feature. And it has a summary of the feature, the so-called description, some tag, and given when then. And I'll write example scenario. And I'll write given some precondition, when some action, then some expectation. I then right-click in this feature file and select define steps and hit copy to clipboard to copy those steps that I just wrote, their glue code. And then my flow is to think in what subset of features should I place them in, and I'll place them in here, for example. Example domain part. Logically, I organize my steps by domain. So if it's shopping cart, I put it to shopping cart, and then in that domain part, I create a class based on domain object that I am automating. In this case, let's say it's example. And I make the class public. I add binding attribute for it so that the glue code that I have will actually be picked up by SpecFlow when I run the tests. And when I have this, it's now enough for this test to be run. So if I delete these parts and try and run my test, and try and see if I can run my tests. So let me build this project for the test to be picked up. So you can see my example scenario, and it points me to the code behind of this scenario. It's scary, it looks ugly, but it's something that you don't really need to explore. If I run this scenario, you will see that it passed. Let me run it again. So it completes. So this is how you approach, how you create scenarios and write features in SpecFlow. It's quite straightforward. What you can write whatever in here and just select define steps, and it will generate the code behind that you can paste in any class you want and organize in any way you want. And then run it as a typical test. And it's organized by feature as a container for many test cases, and then you'll see individual test cases in here. And to showcase this shopping cart feature in action, let me run the tests. Not all tests pass, and that's intentional because not all features are implemented in this page. For example, it doesn't have a look, it doesn't care about how many items are in the stock. It doesn't have the feature implemented for changing item quantity through that text box. That those features aren't done. So to see a failing test, I didn't ignore one test, and to see how ignored tests look like, I ignored those two. So to run the whole thing, let's try it and see how it's run in practice. So this is how it looks like. All those steps that I did are automated and run in Selenium, and I manually would take at least 10 seconds to click everything if I'm on a good day. And all these tests, they took, I think, under 7 seconds. One scenario, as you can see, no more than 200 milliseconds. That's how long it took. So this is how you can use SpecFlow and Selenium together. I won't explain how I laid out code other than I used page object pattern to organize my code. So it's once again human readable and simple. It's worth showing the steps maybe. So all of my steps, this one is probably the most complex step, but they're all written in a way that all of the technical details are hidden against those, under those page objects elements. So other than that, you will see that those steps are quite simple and don't really have much detail. the detail is hidden under the components that they use. So that's quite important when writing steps, to keep them small, simple, clean. But other than that, it's worth mentioning that just because I wrote those features in here, it isn't making my job harder to write this Gherkin. It's documentation that should be written somewhere anyways. It's test code that should be written somewhere anyways. And when I'm able to write code like this in a maintainable way, writing bindings for it is no more difficult than writing some test automation code for anything else. I would say that only the initial parts of writing Gherkin and implementing, adopting BDD, only the initial weeks will be difficult. It's not easy to lay out a good foundation structure for your project, but when you have that, it's no more different and no more difficult than just another automation code. And let's go back to slides. I will now skip to the myths about BDD, because the code part is too detailed, and I recommend just reading the slides and analyzing the code on your part. It's never a good idea to talk about general audience about code specific things when the topic isn't that. So we will skip that and move on to slightly different topics. Unless you have questions about code specifically, then we'll come back to it. So let's continue with myths in BDD. Writing tests in BDD is way too expensive. So for every myth, I would give a question, and I would appreciate an opinion, someone's answer. What do you think about that statement, about that myth? So it's true that initially setting up a project, understanding the practices and preparing might take a few sprints, and it will take time. But is it really expensive long-term to have BDD? Who would like to express their opinion on this question? Or experience, maybe they experienced it firsthand, what problems you had with BDD in terms of time consumption? I'll wait roughly 10 seconds for every question. So we won't hold too long before we wait someone for an answer. So to answer this, to bust this myth, yes, it will take some overhead to prepare, to set the environment, as I mentioned. But in the end, BDD pays off because it adds collaboration. It creates an environment, an absolutely amazing environment for collaboration, for documentation that is human readable, that is verified by automated tests. And after that, after you're prepared, it's just another tool for automation as well. It doesn't add overhead that is a waste. Yes, it creates artifacts that you wouldn't create otherwise, but those artifacts are important, necessary, usable. They're not wasteful. So that's why BDD is useful. It's expensive, but only initially. When you get a hang of it, it pays off. People often complain and think actually that product owners should write feature tests or at least review them. In fact, product owners should not write feature tests because that's not code, but they should review feature tests to verify whether developers understood the requirements. And the problem is when a PO doesn't review requirements, they have a tendency to explain those requirements to people constantly through questions. Because they want to understand the requirements, they ask questions, and product owner spends time to answer those questions. So it's not great. And I'll move on to the answer, but the next one I'll give you the chance to answer. So in BDD, as mentioned, requirements are rarely re-refined because you have examples which supplement our understanding and makes us involved. So when you have examples, you create clearer, more clear requirements, and product owner saves time in the end. It's good because they save time. So that's the paradox. They have an extra activity to review feature files, but they save time by not having to answer questions in order to clear unclear requirements. So the requirements will be so clear that product owner will not have to clarify them again. I already mentioned about this. Product owner and business analyst are not coders. They shouldn't write code. At best, they should review it, but not write it, because they're not programmers. They will not create a maintainable thing. They will not create, they will not think like a tester. Another problem, one person shouldn't write feature tests because the whole point is collaboration. If one person writes it, you lose opportunity of spotting requirements you didn't think about, of making documentation understandable, because you need verification from someone whether what you wrote is understandable. And when a pair of people does it, you will create a thing that's more understandable naturally, because you have different perspectives involved. So this is mentioned, what I already wrote. Let's move on. Some people say that behavior-driven development isn't good if a product is at the stage of already released, developed, and is just maintained. New features are added. If it's a legacy system, they think it's useless to write tests in a BDD way. However, often what happens with legacy systems? We often take a legacy system and break out it to microservices. Usually a legacy system is a monolith and we want to break it out to multiple parts. But the problem is that legacy is often poorly documented and we don't have a good understanding of it. And often when we have user stories that migrate functionality from a monolith to a microservice, it just says in a requirement, make it work like it was before. It should, acceptance criteria literally sounds like it should work as before. That's awful. And actually, if we are content with such an acceptance criteria, we're missing an opportunity to understand the requirements of that system. If we give examples and refine it properly, we actually get the benefit of increased understanding on top of just a user story that tells us that it should behave as before. Understanding, increased understanding is what we want to achieve with BDD. It helps through discovery of user stories through examples. So once again, it's not useless for BDD to be applied on legacy or a product that's already in development, especially if that product had poor documentation. We'll have better documentation with BDD. My question is slightly different here, though. If BDD is applied to an existing product, it's no longer BDD. Why not? What do you think? Why is writing Gherkin scenarios to an existing product not BDD-ish anymore? Why? What do you think? And as you're thinking, there was a remark about tags as a way to create hooks. And yes, that's right. I use tags to create hooks. However, it should be avoided to be used just for that purpose. If you write a tag in a very technical way, that's a bad practice. It should supplement documentation, and you can use it as a hook, as mentioned. In my scenario, the key point why I needed it before every scenario that calls stock, that needs to check how many items are in stock, because my preconditions, when I said that there is enough or not enough items in stock, they messed with database. They changed the state of database. That's why before and after such scenarios that mess with stock, I used tags stock to read and the stock, how many items are in stock, and to reset the stock after the tests are done, to set it back to initial state. That's why I needed the tag, the hook, the tag to form the hook. And the answer is about myth, because there is no development going. You can categorize your tests with tags and use them in your CI/CD pipeline. That's also a use case for tags. But to answer this question, BDD, in this case, I worded it poorly. The development is still going for the product, but the product is already deployed. It's shipped. It's just being maintained and more features developed. And if you apply BDD principles at that point, it's not very BDD because it's test-first approach. And you cannot have a test-first approach when there is already some code. So that's why it's not very BDD, because you already have code. It's practical still, but it's something different at that point, because you don't start from documentation. You start from existing code. Let's move on. Is BDD suitable in all cases? It depends on team maturity. It depends on project scope. It depends on whether good documentation is existing in your team or not, whether the team struggles to understand the product, whether the clients understand the product. And if the team isn't very good at coding, if they complain about the thing, the BDD itself, if they don't want to accept it, if they resist and reject it with everything they have, then maybe BDD is not for you yet. It definitely is good for some cases, but it shouldn't be dogmatically applied for every project. As always, it has a use case, but the team the project lifetime are the two criteria that you should definitely pay attention to. And of course, documentation itself. Maybe you have great documentation, then you don't need anything on top of that. Maybe that's already managed in a different way. BDD solves problems, but it's not the only solution to a problem. Maybe you have a different solution. So you need to evaluate those things. And all that I mentioned, all the scenarios were targeted towards specific domain, things like web or like a rule for parking. But and it might seem like it's not very suitable for APIs, which are technical, and you have a JSON or XML coming in. Is it suitable for testing APIs? And the answer is, yeah, it is. Just because something doesn't have a UI, it doesn't mean that it doesn't have complex behavior. You can still test that complex behavior using BDD. And in the link here, there are 4 ways how to test it. In my opinion, out of those 4 ways, there are only 2 practical ways. So you can either A, provide the request and expect some response back, and that will be your test. Or once again, abstract it away and just say in abstract terms what your input is, and say in abstract terms what your expectation is. Obviously, supply status code, that's probably useful, and supplement it with some extra expectations. Let's move on. Once again, some people just think of BDD as a way of creating a framework which testers could use for writing automation tests. And so a tester who has no automation experience could write automated tests. Developers just provide keywords and testers use those keywords, the so-called domain-specific language, DSL in short. In any case, if you write, it solves a problem. You may use your resources for enabling people who couldn't write tests, they can now write tests. But once again, if you use BDD just for that, if you use Gherkin just for that, you're missing an opportunity of collaboration. Once again, BDD is collaboration first and story exploration. Don't miss those out. By having testers only, you segregate the responsibilities and miss out on the cooperation part. So cooperation first. So BDD is for collaborative development, where we supplement user stories with examples. And like this, we reduce the risk of a bug before we even start developing. And when we write scenarios based on the examples and user stories, we collaborate between a tester and developer. And there is that double loop where BDD and TDD goes hand in hand, where you write tests first. And scenarios, first and foremost, should be treated as documentation. You should write scenarios so that they are readable, easy to understand, and automate that only after. You shouldn't rewrite them just for an easier automation. And like this, you create documentation in sync with code and get living documentation, basically docs proven by tests. And if you would like to learn more, there are 4 books. The bottom 2 books are the ones I based this presentation on, and the top 2 books that I'm yet to read, but are great resources for learning BDD. And actually, in total, there are maybe 5 or 6 books about the topic. So there's really no reason not to read about it if you want to get better at it, because there is this little material about the topic. So you might as well invest your time in what little material there is, because there isn't much and it's worth reading. So there are the links to those books, and that's pretty much it. So thank you for your attention. And now the last part of this presentation is questions, if you have any more questions left. We have 5 minutes, I think, for the questions part.
Almantas, I think that we had one comment from Almantas regarding tags and use them in CI/CD pipeline. Maybe comment something about that.
Yes. So using tags, I'll show you what Almantas meant when I'm using a test explorer, and there's similar thing with CI/CD. I have a way of grouping my tests by some criteria, and I will change the criteria to traits. So as you can see, instead of those by feature tests, I have shopping cart and stock tests. So I am now grouping my tests by tags, in other words. And what this means, that this now gives me a way of selecting a category of tests that I want. And when you're running those tests, let's say in CI/CD pipeline, you can provide arguments, you can provide tags as arguments, and based on those tags, a portion of tests will be run. So for example, I might be having problems with a stock, and I don't want to run my tests based on stock. So I might say, run only shopping cart tests, the ones that are related to shopping cart and not stock, or ignore stock tests. So I have a way to simply supplying tags and running tests based on the tags I selected. So that's the answer to that question. That's how tags can be useful. In testing terms, in generic terms, they're just called traits. That's the general name of the tag. So that's about it. Someone also mentioned tags as a way of creating hooks. So let me show you how I did that. I can use a hook. So a hook in Gherkin terms is, sorry, a hook in SpecFlow, well, in Gherkin too, I guess. In Gherkin, in a framework that implements Gherkin, is just an attribute which you can add on a method, and it will run before or after some part in a test. For example, a scenario, a feature, or all the tests run. So in this case, before every scenario that is involving a stock attribute, I will make sure I will make sure that I set original stock quantity, that I read what the original stock quantity is before stock modified test tag, so that I can later on, after that scenario is done, reset the stock quantity to what it was before the scenario was run. if I don't do this, I will change the state in my tests, and it might impact the outcomes of other scenarios when they run. So in this case, I reset and clean up basically after my scenario is done. You could call this a teardown, like a mini teardown for a scenario in scenario scope. So that's how the tags were used in this case. Any more questions? Like, I will give one small note about the test setup. There is also another hook, not based on tags, that I initialized the driver before all tests ran, so that the same driver would be used, the same browser window would be used for all the tests run. And then I would close the driver after the tests are done running, so that it doesn't, get in the way and it doesn't perform slowly or create multiple windows or open many windows and close many windows during test run. It's both faster and easier to manage. Any more questions?
I think it was a pretty interactive session, Almantas, because lots of questions were asked during the session itself. So if there are no questions anymore, I'd like to thank you. I think that's it, right?
Yeah. Yep.
Yeah. Okay. So if you still have questions, you can of course find Almantas directly on LinkedIn and try to engage with him and into more deep conversation if you'd like to. But for now, I'd like to thank you, Almantas, for a great and I'd say very interactive presentation and answers to the questions from our listeners. So some of them were writing, some of them are speaking out loud. So it was pretty entertaining from our end. And even though we spent over 2 hours already, to me, it didn't feel too long. It was very, very thorough and well explained. So thanks for sharing that a lot. So in general, thank you all, everyone who joined our 7th automateIT online meetup. It was really amazing to have you all here gathered here today. And thanks again to you, Almantas, for a very clear and detailed presentation. And of course, since automateIT is powered by ZeniTech, special thanks to ZeniTech as well.